Hello, my name is Michael Wehar, and I will be presenting a joint work with András Salamon. In this work, we investigate limited nondeterminism and conditional lower bounds. We also make connections to the log circuit SAT problem and the exponential time hypothesis. So the first thing I should talk about is limited nondeterminism. This refers to the restriction or bounding of the amount of nondeterminism in a computation. There are many existing notions of limited nondeterminism, and some of them are equivalent to each other, and some might potentially capture different classes of languages. We actually introduce a notion we call DTW. We give a formal definition of this, but for the purposes right now, you can think of T of n as being a time bound and W of n being a witness length bound. So one of the core questions we asked is, can we beat brute force search with some of these kind of low-level limited nondeterminism complexity classes? So the one class we especially looked at was DTW n comma log n, and we asked if you can beat quadratic time. Basically, quadratic time is what you'd get from brute force search. Ultimately, we were unable to resolve this question, so we decided to consider conditional results. In particular, we considered how faster algorithms for the DTW n comma log n class might translate to faster algorithms for the n time n class. You might expect that an improved deterministic simulation for one would lead to an equal improvement for the deterministic simulation of the other. But this turns out to not really be the case. We were actually able to show that if we can get an exponent of alpha for the deterministic simulation of DTW n comma log n, then we would get an exponent beta applied for the deterministic simulation of n time n. And this exponent beta is actually smaller than alpha. And the reason we're able to do this is because we introduce these speed-up theorems that allow us to apply our strategy of potentially beating brute force search over and over again. And we hope that you'll attend our talk where you can learn more about these speed-up results. Thank you very much.